We will be creating a stock screener in Power BI that helps us find stocks trading at discounts using fundamental comparative analysis. The Power BI and Excel Cleaner are available on my Patreon. Thank you for your support. So, what even are price and value in the stock market? Price is the stock's current price investors are willing to pay, while value is the intrinsic value that a stock is actually worth based on fundamentals. You wouldn't want to pay more for something than it's actually worth, right?
Man, was I using mine wrong? How much?
$5.
I've only got 7.
Deal.
In the words of Warren Buffett, price is what you pay, value is what you get. The current price of a stock might be $200 today, but your own analysis suggests the company should be worth $250 per share. This is where fundamental analysis comes in. We can spot undervalued companies and buy stock at discount prices. One way we can unearth value is comparative analysis, where an investor will compare a company to similar companies using key financial ratios like price to free cash flow and EV to EBITDA. If a stock is trading below the industry average ratio, then the stock could be trading at a discount. Price to free cash flow tells us how much investors are willing to pay for every dollar in free cash flow the company generates. While EV to EBITDA is the company's enterprise value versus operating cash flow. Enterprise value is equal to market cap plus debt minus cash. But what does it really mean to minus cash? Cash that is idle, sitting around, has no operational value to the business. So, with inflation, if a business just sat on cash, then they would actually be losing value over time. If we found a cheap stock where investors are willing to pay $5 for every $1 in free cash flow, while the industry average is $20, we could argue that the company has room to grow, especially if the free cash flow is growing faster than the industry average as well. This makes us question, why are investors only willing to pay $5 for this company when on average in this industry investors pay 20? Now that we understand the difference between price and value and how comparative analysis can help us find potentially discounted stocks, let's create a stock screener in Power BI. Data we will use comes from TradingView's stock screener, and we'll select relevant columns like price to free cash flow, market cap, and EV to EBITDA that'll help us do further analysis in Power BI. Here is the TradingView stock screener. If you go to products, screeners, we can select stocks. And this is the default view. But for our own personal stock screener using fundamental analysis, I'm going to remove these columns that we are currently not interested in. Okay, great. So I want to keep price, I want to keep market cap, and I want to keep the sector that we are in. I think something interesting would be industry. So I'm going to add that. And then I'm going to also add free cash flow. So let's get the annual free cash flow. Let's get the free cash flow growth, and we'll do annual to match our free cash flow column. And then we could do price to free cash flow. And this is what we're going to compare companies against. We also talked about EV to EBITDA. So let's do enterprise value to EBITDA ratio. We can compare stocks with that ratio as well. And then let's filter on a sector that we are interested in. So, perhaps we want to look at producer, manufacturing. Let's look into that one. So we got 415 stocks. So this is a pretty good, pretty pretty decent data set. So there's no import button from TradingView from what I can see. So I'm going to cheat a little bit and highlight the values that we see here, copy, and then we can paste this into our Excel spreadsheet. Alrighty, now we have copied and pasted the TradingView stock data into our Excel spreadsheet, but we could see some data issues like the text USD in a numerical field, so we'd probably want to take that out. We have market cap with a B standing for billions. If we scroll down, we're going to start seeing different terms like M for millions, and then keep scrolling all the way down, and we'll start to see K for thousands. So we'd probably want to multiply by the appropriate amount to get the numerical value for market cap. And we could also say the same thing for free cash flow. Percentages, we'd want to change that into a numerical type. So there's some data cleaning to be done. And this Excel spreadsheet, the stock screener cleaner, is capable of doing that. So if I go to the cleaned tab, we can see that the market cap dollar was cleaned according to the text value that Excel detected. So if market cap had a B in it, that means we're in the billions. So we have to multiply the value by the billions. We do the same thing for M and K for million and thousands. And this cascades all the way down in our data set. Same thing for free cash flow. We can detect whether or not the free cash flow was negative. We can also detect the appropriate amount to multiply according to billion, million, or thousands. So we cleaned up the free cash flow, we cleaned up the market cap, and we cleaned up the EV to EBITDA. So now we converted our text values into numerical types, and I'll make this Excel spreadsheet available in the Patreon for you to use. To review the rest of the code with you, we have free cash flow dollar. That's what that cleanup looks like. We have free cash flow growth. This is what the code looks like for that column. Price to free cash flow was a bit simpler, just taking out that negative value and substituting it for blanks. Same thing for EBIT to EBITDA. And I added a date of data column just so that we know internally when we took this data as a snapshot in time. All right, now we are in Power BI. So first, to start off, we're going to need some data. And our data currently lives in an Excel workbook. So we can click that. And you can see that I called our Excel spreadsheet the stock screener cleaner. So I'm going to open that one. And then it's going to connect to our Excel spreadsheet. And I can select which tab I want to use, either cleaned or raw data. I'm going to select clean data since that's going to be a bit more useful for us in this analysis. And it's going to open the Power Query. So our query settings, we can call this stock data. And then all these data types look pretty good. And there's some errors going on in this one. So I'm kind of curious to see what is wrong with this data set. And we're getting an error. So it looks like this error is happening because of this text value. So it's trying to convert market cap dollar into a numerical type, but that's not possible because of this error. So why don't we go back into our stock screener cleaner spreadsheet and see what we could do about that. So this is where the issue is happening, right? So what if we said if Well, should I should probably start at the very top. So let's say if this value is equal to that, then return nothing, and then see if that helps us. You're seeing me demo or debug live here. So okay, so it's returning false, so that's good, right? Question mark, maybe. Um, but these are all false too, right? Did it used to be false before we made that change? These were actual values. So we don't want to get rid of those, right? So having those come as false would be not a good thing for us. So I'm kind of surprised that forcing it to be that. Okay, yep. And then we should just say C2 at the end. All right, let's try that. There you go. Okay, so now we don't have these values coming over. So that's a good thing. So now we shouldn't have errors in our Power BI data set. So I'm going to save that. And what's great about Power BI is that once you create a data source connection, you don't have to input manually that data, right? You can just refresh in Power BI. So let's see what happens after we refresh the data set. And I'm going to say refresh all. Okay, great. So instead of an error, it says null. And now we don't have any errors, right? We have green, so that's good. Gray means null, and that's good. So there's no errors in our data set anymore. So that's perfect, right? So with that being said, free cash flow as a numerical value, that looks good. Free cash flow, numerical. These are numerical. That's a date type. That's good. I'm happy with this data set. So I'm going to say close and apply. And then it's going to load up this data into our Power BI. Okay. Sweet. So now we can start doing some analysis on this data to see if there's any stocks in producer manufacturing that's trading for a discount. So I think what would help first is we can just create a raw table and we could get the symbol in there, right? So here are all of our companies in our data set. I'm going to get the dollar market cap. So then I could order this by the most expensive company. It looks like Caterpillar, followed by Deere. And then let's get the price in there too. I want to see how much is each stock worth. And then we could do free cash flow of the dollar. What's the annual percent growth of free cash flow? And I could change this into a percentage. So let's do that. And then I want to look at EV to EBITDA. And not summarize that. And that looks good to me, right? So this is the core of our data. So now I want to see which stocks are trading at a free cash flow and EV to EBITDA discount. So let's get a filter in here. We have the industry, and then we also have the sector. So I'm seeing these zeros come up in our data. So I might not want that in our data set, right? Because that's not a valid value. So we can go back into edit query and see if we can clean this up a little bit better. If we scroll down, we're going to notice there's like these values. There's a text value called D, which doesn't really tell us anything, right? And that's where our zero value for the industry and the sector is coming from. There's these zero values, all these D symbol values are null. And this is because I think if I'm correct in TradingView, the D next to a symbol stands for delayed. So maybe the data was delayed in the stock screener. And we're seeing a lot of these D values that we really don't need. So let's go to the drop down in symbol, and we can actually remove these D values. So it's right there. So I'm going to unselect it to remove it from our data set. And then this should be a bit more cleaner. So let's close that and apply. So I'm still seeing these zero values. So we can also go into industry and remove it that way. And that way, at least our slicer looks a bit cleaner. So now, these companies to select from. This list is kind of large, so I can go into drop down mode. That way I got more real estate. And let's see how many stocks we currently have in our data set. So if I go to symbol, it created a new table. If I go to symbol and I do count distinct, so there's 171 symbols, stocks in our data. So let's say we have 171 stocks in our data set. And if I click through, so building products, there's 12 stocks in that data set. Electrical products, there's 32. Industrial conglomerates, there's 4, etc. So I want to dynamically calculate the average price to free cash flow and average EV to EBITDA for these different industries. So I can click new measure and I could say average price to free cash flow. And I could do calculate, or rather I could just say average stock data price to free cash flow. So this is going to calculate the average price to free cash flow for me. So here you go. So I get 25.39 for the average price to free cash flow. And this value is going to change as I select the industry. Like building products is 23, electrical products is 72, so on and so forth. And then if I put price to free cash flow in my data table, I'm going to see, okay, CNH Industrial trades at a price to free cash flow of 8.9. The industry average is at 25. So could it be argued that CNH is trading at a discount? And that's where further research would have to go into understanding that stock. We can do the same thing for EV to EBITDA. So if I go to new measure, rename this EV to EBITDA, I can say EV to EBITDA. And then I'll get a new value, 59.82. That's the industry average. So for example, we could see perhaps these companies, they're trading at a premium because the average EV to EBITDA for this sector is 59, while these companies are trading for double, even this guy, YHGL ticker 4,000 EV to EBITDA. We can also argue that perhaps this is an outlier and we should take it out, and that could be for another video. But the average EV to EBITDA for industrial machinery is 24. The average price to free cash flow is 22. So then we could take this a step further. We can say, what is the average growth rate of free cash flow? Free cash flow growth, average growth free cash flow. I'm going to move this. And then I could get average growth free cash flow. That's going to be a percentage. So interestingly enough, it's actually negative. So that on average, the free cash flow growth rate is negative for this industry. So now we have industry metrics. I'm going to give this a title so that we know what we're looking at. So these values here, these are industry metrics, right? The count of stocks that we're accounting for is 48. The average free price to free cash flow, average growth, and EBITDA EBITDA. Now we want to pin these stocks against these average metrics and say which ones are growing faster than the industry, which ones are trading at a discount price to free cash flow, and which ones are trading at a discount EBITDA EBITDA. So the next step of that would be to create a column. I think that would be best. Better yet, so unfortunately, like in Power BI, you can't use a measure as a filter. So what we can do is create a column and say industry average price to free cash flow. And then we can say average price to free cash flow in our stock data table. and say industry. So this is saying return the measure that we just created, average price to free cash flow, respective of the industry type that we're in. So I'm going to say okay to that. Because if I were to take the measure that we created, which was the uh, average price to free cash flow, if I drag this over into our table, since our table drills down to the individual symbol, it's just going to take the average of the one thing, which is itself, right? So average price to free cash flow on this table is not really helpful because it's taking the average of itself, right? So I'm going to remove this. But thanks to our new column, I could drag that over and notice how the 22.47 matches the 22.47 here. Now we can say, hey, 22 is greater than 12. That means perhaps KLIC ticker industries is trading at a discount. So that's the goal there. Instead of having to compare within the table, I think it'd be more convenient if we created a filter. So let's do below average free cash flow. So I could say if so if the price to free cash flow is greater than zero, because if a company has negative free cash flow, then they can't have a price to free cash flow multiple. So we only want to consider for the stocks that have a valid price to free cash flow value. So we have price to free cash flow is less than the stock data industry average price to free cash flow. So if both of those are true, we're going to say yes, and then else is no. And then we're going to exit that out. I think another thing that's important for us to do is look at the average price to free cash flow. So let's make this filter a bit more conservative and say that, hey, we're only interested in looking at stocks with a market cap of greater than 100 million, right? So three. Okay. Good. Perhaps we could argue that, smaller market caps, more volatile, they're not mature companies yet. We might not want to analyze those yet. We could also say the raw free cash flow should be greater than zero, right? Because we only want to consider stocks with a valid free cash flow value. If it's negative, they won't have a price to free cash flow. So I'm going to calculate that, and then it got mad at me. So why would it get mad at me? Type text with value of type integer. Oh, market cap dollar. The market cap column has text values in it. Okay, so 25. So that didn't really, if I remember right, that didn't really change much. So that's good. Um, so now we can go back to the filter that we were working on. Below average free cash flow. We already wrote that. So let's create a slicer and use below average free cash flow. And if I select yes, notice how we filtered out 30 stocks. We used to have 48 stocks in this list. If I say, hey, only return below below average free cash flow, we're going to get price to free cash flow, for example, 12 compared to 16. Notice how the industry metrics changed. I really don't want the industry metrics to change. So I can go to Format, Edit Interactions. I'm going to turn these off, and I'm going to move this text box because that's in the way. So notice how we're back to 25 for the industry metrics. And that's what we want. We don't want to impact the industry values with our filter. So I'm going to bring this back down. So perfect. Now we have price to free cash flows less than the average. But maybe these stocks should trade at a discount. Like for example, this guy right here, their price to free cash flow growth was 88% down, right? It was negative 88% compared to the industry average of negative 84. So that stock's annual free cash flow growth was lower than the industry. So maybe they do deserve to trade at a discount. So now I want to filter on stocks where the free cash flow growth was greater than the industry. And we can do the same thing and create a new column. I could say free cash flow growth is greater than the industry average. And I might need to make, yeah, I'm going to have to make this value first. So I'm going to cancel that. I'm going to create a new column, industry average free cash flow growth. And then say average growth in free cash flow. I'm going to hit OK. And now I could create the above average free cash flow growth because now I want to see the stocks that are outperforming. So free cash flow growth is greater than the industry average free cash flow growth. And I'm going to select OK. And I actually don't need the and because now there's only one argument or one condition to be true. I'm going to copy paste my filter. And now I could say above average free cash flow. So show me the stocks that are growing faster. So First, we had 48 stocks. Show me below average free cash flow. Now I have 18 stocks. Now I'm going to select show me above average free cash flow growth. I filtered out one stock. So now I have 17 stocks that I can analyze. Maybe I want to take this a step further and say, I want strong companies. I don't want companies that are, you know, dim- dropping in free cash flow growth. So I'm going to say, they got to be greater than zero as well, right? And it got mad at me again. So why is that? Oh, it's because of some syntax. Okay, so that dropped our population down a lot, right? We were at 17, now we're at 9, so eliminated half of the search space. And these stocks are also trading at a discount in terms of EV to EBITDA. For example, notice how GTLS ticker chart industries, they grew free cash flow 11%, while the industry as a whole went down 84% in free cash flow annual growth. But this company is doing a good job, 11% up annually. Price to free cash flow, though, they're trading at 15 compared to the industry at 25. And then finally, EV to EBITDA is at 10 when the industry is trading at 24. So this can be a starting point for value investing analysis saying, hey, why is GTLS trading at a discount? Do they deserve to be trading at a discount? On the surface, it doesn't seem like it, right? Because they're growing faster than the industry average. So now we're thinking, okay, great. We have a list of stocks. I can select the industry type and it'll filter for stocks trading below the industry average instead of having to manually sift through these, right? We created a system that will filter it out for us. But what is the potential price that these stocks could go to if they were to ever trade at the industry average? So we can create potential price values given current ratio that these companies trade at. So, with that being said, I could create a new column and let's call this potential price using price to free cash flow. So, stock data, we're going to use the stock's current price, and then we're going to divide stock data, the industry average price to free cash flow, and then stock data price to free cash flow. And this is going to help us derive a new stock price, assuming the stock might one day trade at the industry average. So, for example, we were looking at GTLS charts industries. Current price is at 152. If this stock were to trade at the industry average, it would be $254 using the price to free cash flow multiple. So, what is that from a percentage standpoint? So, I can use a percent change formula. So, let's say potential price change, price to free cash flow. So I'm going to say stock data is our data source. The average potential price, I'm going to substitute that with potential price and then the actual price. And then this is a percent change formula. And then once I add that, so this trade here would be a 66% increase from 152 current price, potential price using free cash flow multiple 254. That's 66%. So, these stocks have potential, assuming they might one day trade at the industry average. We can also color code these. So we could do conditional formatting. Let's say we want to change the font color. We could do some rules if it's greater than or equal to 0. We could do max. And then we could say, hey, I want green values if it's greater than 0. If it's less than 0, I'd probably want it to be like red or something, right? So there you go, right? So we have these values. It's red if the potential price is less than the current price. And there you go. And we could repeat this for EBITDA EBITDA, right? We can create, hey, does EBITDA EBITDA trade below average free cash flow? If EBITDA EBITDA trades below that average, we would be curious to say, hey, what is the potential price target for this stock, assuming it trades at the industry average? So now you have a stock screener, and it helps you find potentially discounted stocks. And this makes for a great starting point for analysis. So let's say I'm interested at chart industries. This is where I would go to, the 10K and the quarterly earnings and read up about their financial story and see whether or not GTLS deserves to trade at a discount, or say no, the discount is overdone, it should grow in value. So I hope you enjoyed this video. I will have this Power BI available in the Patreon. So link to the Patreon is in the description. I do appreciate your support on the channel, and thank you for coding along with me today in Power BI and Excel. If you enjoy Power BI content, I'm happy to do some videos on that. I've done a lot of Python videos in the past, so branching out into Power BI instead, let me know if you enjoyed. And I will see you all in the next one.